ठीक है, तो ये लेते हैं, स्नाइप करते हैं, इसको ले जाते हैं वहां पे, इस पे लेट्स डिस्कस दिस प्रॉब्लम। क्या क्यों नहीं हुआ? दिस इज द प्रॉब्लम, ठीक है ना? What it asks is this, find the load. P, find the load. Find load so that number A, factor of safety against shear failure is greater than or equal to 3. B, consolidation settlement, that is delta HC in 10 feet clay layer is less than equal to 1.5 inch. This is the design requirements, ठीक है ना? Shear failure, for shear failure, it has given you the properties of silty sand. C equals 0 and phi equals 30 degree. For consolidation, it has given you the of E versus log sigma prime curve. Use these to find the load. ठीक है ना? So let's first use the first criteria, which is shear. Shear criteria. So use Tarzahi equation. Q ultimate in terms of gross gamma D and Q plus 1 over 2 gamma B and gamma into S gamma, because it is a square footing, ठीक है ना? N gamma into S gamma, right? अच्छा, that will give you a gross pressure. In order to find QU in terms of net, you would use QU is equal to QU, oh my God, QU in terms of gross, oh my God, oh, QU gross minus gamma into D. If you use these, the value of this term is you see QU gamma D, this gamma D, you put the values and you would get QU gross equal to 24.2 KSF. 24. क्या हुआ? अच्छा अच्छा कैसे and this would be equal to 20 minus gamma d is 23.1 KSF. Now you need Q safe in terms of net would be equal to QU in terms of net divided by factor of safety, which is 3, and that is equal to 7.69 KSF. Allowable load P safe would be equal to Q safe in terms of net into the area of footing AF, that is equal to 492 kips. Now the second criteria. Second criteria is about the consolidation settlement. Delta HC in 10 feet clay layer, right? Now we need to find out delta sigma average, right? We need to find out delta sigma average. We need to find delta sigma average, that is increase in stress due to load, average stress increase in 10 feet clay layer due to load P. ठीक है ना? A load that will cause 1.5 inch settlement. ठीक है? So we need to use consolidation equation. We need to use delta HC equation. But which one? Which case? Case 1 or case 2? Let us assume case 1. Let us assume case 1. Delta HC is equal to CR over 1 plus E naught H naught log 10 actually sigma naught plus delta sigma over sigma naught, right? So in this equation you know everything except delta sigma. Sigma naught you already know from previous. Sigma naught from previous example is क्या है, याद है किसी को? It is 1.841. You can see 1.841. 1.841 KSF, right? And delta HC you put 1.5 inch, right? From this equation, in this equation you know now everything except delta S. So 1.5 inch divided by 12 to bring it into feet. CR value is already given 0.035. 1 plus E naught is already given, equal to 0.96 into H naught is 10 feet into log 10 sigma naught is 1.841 plus delta sigma need to be found out divided by delta sigma. Now, sigma naught. From this, delta sigma is equal to 7.385 KSF. So let us check if case 1, if our assumption of case 1 is right. Okay? So delta sigma naught plus delta sigma should be less than or equal to sigma p prime. But you see this is not the case. Sigma naught is 1.841 plus delta sigma is 7.385 this is greater than sigma p prime, which is 3 KSF. Should be less than or equal to. Okay. So our assumption is wrong. Case 1 applies. For case 1, we know that delta C is equal to Cc from this equation, sigma p, now delta sigma is now equal to 1.55 kips. Right? 1.55 KSF. Now use slope to 1 method. ठीक है, चलें यहाँ पे आ जाते हैं. Now use slope to 1 method. To find P, delta sigma is equal to P divided by B plus Z1 divided by B plus Z2. From this equation, P is equal to 520 kips. Other P net is equal to क्या है 520 kips. So you have two criteria. From shear you got 492 kips. From settlement you got 520 kips. So allowable P is 492 kips. The least of the two you should select. This is the solution of your problem. Do you have any question? इस पे कोई शक शुबहात है आपके?
No, sir.
अच्छा, good. Let's solve the same problem but using Bosniak equation. Using Bosniak equation. And let me see. I have one. अच्छा, आप इस तरह करें कि यही प्रॉब्लम बॉस्निक इक्वेशन से कैसे सॉल्व करेंगे. इंस्टेड ऑफ स्लोप टू वन मेथड you use Bosniak equation, right? I give you few minutes to ponder upon this problem. To solve this using Bosniak equation, right? Here it is already solved for you. See, you can do that. Here it is. Shear criteria would remain the same, 492 kips, as you have done that. For settlement criteria, you divide the layer into 5 sub-layers. You see in the diagram, like you have done previously, each 2.5 feet, right, and generate this table. You have 5 depths, 6 feet, 8.5 feet, 11, 13.5, and 16. Because we want to find average stress increase using Bosniak equation, so you have to develop this table like you have done it before. M is 0.67, N is 0.67, is the same table. I sigma is not 0.121, rather it is 0.121. It is 0.121. Here you go. There was a bit mistake. Let's correct it. Here you go. Now delta sigma average is Q naught M into I sigma. The M value is 4 because there are 4 corners. You want to find out average stress increase under the center of footing. So M is equal to 4. Q naught is the applied pressure, but you do not know the value of Q naught because you do not know the value of P. And P is the one that you wanna find it out, right? And I sigma is 0.121. So you multiply 4 with I sigma, you get 0.48. Similarly this, so you develop this in terms of Q naught. Now use Simpson rule to find the area under the curve. Use the Simpson rule, but remember that again the area will be in terms of Q naught. You divide this area by the height, you will get average stress increase again in terms of Q naught. After you find delta sigma average in terms of Q naught, you can use delta C equation. Let's assume that case 2 applies and you will have this equation. In this equation, you know all the values except delta sigma, right? Except delta sigma. So put delta sigma here and you will have the whole equation in terms of Q naught and you can find Q naught from this equation. So I encourage you to input the values in this equation and find me Q naught and then P. Now you know all the values. You just put in the values in this equation and give me Q naught. जल्दी करें, ये तो कर सकते हैं ना, ये कर ले. जी जल्दी करें. जी क्या आंसर आया? क्या आंसर आया? जी क्या आंसर आया? Delta AC is 1.5 inch divided by 12 plus, okay, is equal to CR value is given 0.035 divided by 1 plus E naught. उसकी क्या वैल्यू थी? Let me see. Point 035, 0.96, 0.32. 1.96 into 10 feet into 12 inches is 120. Okay, okay, 10 feet, sorry. 10 feet into log sigma P is 3 KSF, sigma naught is 1.841 plus CC is 0.32 divided by 1.96 into 10 into log sigma naught 1.841 plus delta sigma, and delta sigma is 0.23955 Q naught in terms of Q naught divided by sigma P prime, which is 3 Ks. So this is the equation. From this equation you find out the value of Q naught, and from here you can find P net is equal to Q naught into area of footing, and that would give you a value equal to 416 skips. So here settlement governs and P allowable is equal to 492. ठीक हो गया? अच्छा जी. Any question? Any question?
No, sir.
Okay.
No, sir.
Good. Good. अच्छा, अब नेक्स्ट प्रॉब्लम पे जाते हैं. This is another problem. You see, let me snipe it. There is nothing new in this problem. What it asks is to find out consolidation settlement for silty clay number 1 and for silty clay number 2, right? The consolidation properties are given, are already given. They are here. This is for silty clay number 1 and this is for silty clay number 2. So you apply the equation to find consolidation settlement for silty clay number 1. For silty clay number 2, the problem is the same. The problem is the same, but there is a one thing tricky, a bit tricky, and this is what should be the thickness H naught to be taken for silty clay number 2, because there is no thickness given. You have drilled a borehole up to silty clay number 2 to some depth, but after that you terminated your borehole, right? And you do not know actually what is the thickness of silty clay number 2. So what you would do, you would consider a pressure bulb. You would consider a pressure bulb like this. A pressure bulb, would it work? No. This is the pressure bulb under the foundation, right? This is a pressure bulb under the foundation. The depth of this pressure bulb is the depth of this pressure bulb is 2 times diameter of the footing. 2 times diameter of the footing. That is 2 into 50 is equal to 100 feet, right? And the intensity of this pressure bulb, as you already know, is 0.1 times or 10% of Q naught. Or 0.1 times Q naught, right? We already know. So the remaining thickness is from here to here, from here to here. How much should this be? How much should this thickness be? We know that thickness from here to here is from here to here is 75 feet. So this thickness would be 100 minus 75 is equal to 25 feet. So your H naught is equal to 25 feet. Now the problem is easy. You use the equation and solve the problem, right? The answer is given here. You just put in the values, get the answer. For silty clay number 1, it's very easy. It's 24 inch. For silty clay number 2, 2D is 100 feet, H naught is 25 feet. I explained it to you how it is coming, and that would give you delta is equal to 0.3 inch. There's another problem here, right? There are two things important in this new and important in this example. It is also solved here, right? So you would not have any problem. Just understand what is new and tricky in this problem. This is a water tank, a huge water tank or oil tank, right? It is a tank, 100 feet in diameter and built 5 feet below the grade, ground surface, right? The soil profile is 10 feet stiff fissured clay, and we do not expect any kind of consolidation settlement in this layer, as the water table is below this layer, and now we have a soft clay, right? The soft clay, which is 8 feet, is subject to consolidation settlement, and the consolidation properties are given, right? So the first thing which is important is the load applied by the tank is the water and the self weight of the tank itself. And this load is already given to be equal to 2000 pounds per square foot, right? But you know that settlement is caused by net pressure, not the gross pressure. The gross pressure here includes the weight of the water or oil, the liquid that is in the container, and the self weight of the container makes the gross pressure. But you see, there is also some excavation before the construction of tank, right? And the excavation is 5 feet deep. So actually you have removed some soil because of the excavation, and the pressure that you have removed is gamma into D. So the Q net would be equal to Q gross minus gamma D. Here you see Q net is equal to Q gross, and gross you know is the pressure weight of the self weight of the tank plus weight of the liquid. Yeah. Or gamma D is the excavation pressure. So the net pressure is Q net. So this is the net pressure that you would use in the calculation, right? This is the net pressure here shown by red arrows that would be applied on the base of the footing, right? The second thing important is this, because And TV, after finding TV, you can find T, right? Okay. Now this is the problem. We would use that equation here and solve this problem. We have this soil profile, soft blue clay which is 80 feet thick, sandwiched between two fine sands, right? The consolidation characteristics are depicted by these graphs. This is void ratio versus log sigma prime curve, and this is C versus P curve or pressure curve. What is C is the coefficient of consolidation. Its units are centimeter per second, right? On this soil profile, is this foundation going to be constructed, and loads on this foundation are already given. What we need to find out the time versus settlement for column number 5 and column number 9, right? The procedure is same for column number 5 or column number 9, right? Much of the data has already been given and you need not to find them out. What is given is the final value of settlement, right? For column number 5 it is 4.5 inch, for column number 9 it is 3 inch. So we would consider 4.5 column number 5, right? 4.5 inch. This is the final settlement. What else is given is average stress increase in the clay layer is 0.3645 KSF, already given. So you need not to use Bosniak equation, divide the layer into sublayers and Sampson rule. You don't need to use it because it is already given. Present defective overburden pressure at midday of clay layer is 6 KSF. Sigma naught prime is already given, 6 KSF. So much of the data is already given. So what we need to do is to draw such like curve. This is time in years, this is settlement inches, this is column number 9, this is column number 5. How can we do that? Let's do it, right? Here is already solved for you. Mobile data में आंधा बोलिए ना पासवर्ड दे Khan 1 2 3. So first of all you would assume different values of u, 0, 0.1, 0.2, 0.3, 0.4 down to 0.99, which is almost end of consolidation, and 0 is start of consolidation. TV you can find from this equation. You see here, when u is less than 0.6 you use this equation, when u is greater than 0.6 you use this equation. So you would get these TV values. From this TV value you can find T using this equation. You see T is equal to TV d square by CV. What is D? TV you can pick from this table. And what is D? D is the longest drainage path. D is the longest drainage path. And you see here in this profile for soft blue clay, which is 80 feet thick, there's fine sand up and below. So it is doubly drained. So D would be equal to H by 2. That is half of this layer, 40 feet. CV is the coefficient of consolidation given as 0.0035 centimeters square per second. So you use TV from the table, D square 40 feet, CV here. Use the consistent units and you will get time in second. Divide this, convert this second into years. This is, you will get this. Final settlement for column number 5 is already given, equal to 4.5 inch. You can find ST by multiplying final settlement with U. You see here, you see, multiply, and then plot it here. This is time in years and this settlement in inches. Let me this is time in years and this is settlement in inches. So this is how you can solve this problem. From where I got, so this is the end of your chapter, but let me say a few words about CV, which is 0.0035 centimeter per square centimeter square per second. How I obtained this from this graph. How did I obtain it from this graph? Here on the x-axis you have pressure in the 8 feet clay layer, average pressure in the 8 feet clay layer, and on the y-axis you have C value, right? So let's find average pressure in the clay layer. 6 is the initial pressure if before the construction of foundation, and the final pressure is 6 plus 0.345. The average pressure is 6.17 KSF, which is equal to 3.1 kilogram per centimeter square. You put this 3 here, 3 is 2, this is 3 here, and you see the CV value is 0.0035 centimeter square per second, right? So this is the end of your chapter. If you have any question, you can ask so that we can start Viva.
नो सर
Oh.
सर ये